full screen. There we go. Everybody should be able to see that now. All right, fantastic. Good morning, everybody. This is April 21st. It is first period A1, Algebra 2 CP. Hopefully everybody had a fantastic weekend and is having a fantastic start to your day. Couple reminders before we get started. First thing is, as usual, make sure you do fill out that quick attendance form on Google Classroom. Just takes a couple seconds. It's the same one we've been using all along, just to mark that you are present for the day. It's especially important considering it's first period. Secondly, make sure that your microphone is muted and your webcam's disabled, which I believe they all are. Again, if you do have a question, though, as I'm going through this, please feel free to interrupt me and ask, okay? Don't feel like it's going to be inconvenient or I'm going to get annoyed at you. Please make sure you interrupt and ask. You can type or you can just unmute yourself and talk. Either way, whatever you feel comfortable with. Another thing I want to remind you of is please make sure that you've been checking your email regularly. Hopefully you all did receive my email yesterday, which described, or at least I attempted to describe in as much detail as possible, how the structure of our Algebra 2 class is going to be going forward into the fourth quarter. I know that as of now, we are only confirmed to be in distance learning until the start of May. However, I did just want to develop a plan just in case. So, of course, that plan is contingent on distance learning still being a thing. But I did want to make sure I had that plan in place to give us some structure going forward for the fourth quarter. Essentially, the way it's going to work is at the end of every class, just to summarize quickly, you should read the whole thing. Make sure you do read the whole thing. At the end of every class that meets on a Tuesday, so that being today, I am going to provide you with practice work. I believe did I already upload it on Google Classroom? If I didn't, I'm going to upload it very soon. I think I just have to make the answer key, and I'll go ahead and upload that on Google Classroom. The practice work that you get after classes on Tuesday will not be a graded assignment. It's just extra practice for you with the answers so that you can just do that practice work on your own. It only benefits you. However, after every class that meets on a Thursday, that is when I'm going to send out a graded assignment via email. Okay? You may be familiar with the fact that in the fourth quarter, all graded assignments count equally. That is 100% true. So do make sure you complete those assignments. When I give you a graded assignment after a Thursday class period, it will be due on Sunday night, by Sunday 11:59 p.m. on Sunday night. The reason, again, I typed it all in the email, the reason for that Sunday deadline is so that I can have time to grade it on Monday and get that back to you with the answer key. Because I do think that's a lot of time, that's Thursday afternoon, Friday all day, Saturday all day, Sunday all day, I think that should be plenty of time to account for any inconveniences at home or any unpredictabilities or technical issues. So I am not going to be accepting late submissions on those. Okay, at 11:59 p.m. Sunday night, that's exactly when it's going to be due. Okay, and like I said, I think that's plenty of time. That's a big enough window for you to get those assessments done. So again, just to recap, after Tuesday classes, you're going to get practice work. It's not graded. I encourage you to do it because it only benefits you. The answers will be provided with those practice worksheets as well. After Thursday classes, I will send out a graded assignment via email. You're expected to take pictures of your work, send it back to me, just like you did with the previous assessments, and those will be due by Sunday night so that I can grade them Monday and get them back to you. All right? Does anybody have any questions on that classroom structure? Hopefully that answers everything you need to know. Again, the email that I typed out should be a lot more detailed and whatnot as far as that's concerned. I was having issues, and unfortunately these issues are still going on, with my webcam kind of freezing, and I don't know why it's doing this now. Oh, I got my great day to be a clipper thing. It's like clicking off and on, so all I have to do, I'm pretty sure, is I just have to, where'd it go? Just have to deactivate and activate it again. It should click back on. It's really weird that that's been happening. I don't know why that's been happening. I got to check like the connections and stuff that I'm plugged into, but maybe it's just getting old. I don't know. But hopefully that doesn't happen during the lesson. If it does, the document camera should still be working. I'll just go in and click it off and click it back on quickly. All right, so without further ado, let's go ahead and start learning about some more rational functions. Today, what I really want to do is just do a bunch of examples of graphing rational functions with you. So I wanted to start by just reviewing the stuff from the previous class. In the previous class, you may recall, we talked about graphing rational functions. A rational function, again, being any function that has an x in its denominator. Now, the way that that's done is the first thing that I'd like to do is try to identify my asymptotes. There is a vertical asymptote and an end behavior asymptote for every rational function. How do we actually find these? Well, first of all, to find your vertical asymptote, you want to find the value for x that would result in dividing by 0. So if I look at my little example function like this, the value for x that results in dividing by 0 is just x equals 1, because 1 minus 1 would be 0. And the reason, again, that we look for that is because dividing by 0 is bad news in math. We can't divide by 0. It breaks one of those cardinal rules of math. Doesn't make sense. Okay? So that creates what's called our vertical asymptote. We then look for our end behavior asymptote. In order to find the end behavior asymptote, we compare the degrees of the numerator and the degree of the denominator. There are three cases that can occur if we're comparing two things. Either the first one's bigger, they're the same, or the second one's bigger. So if the degree of the denominator is larger than the degree of the numerator, then your end behavior asymptote becomes 0 plus your vertical shift. Again, the degree refers to the value of the highest exponent to which a variable is raised. Okay, so that's what I mean by the degree. So for example, in our little example problem, the degree of the numerator is 0 because there are no x's at all. The degree of the denominator is 1 because you have x to the first power. So it would satisfy the first case, and our end behavior asymptote would be 0 from this piece plus the vertical shift of 3. So you can see here in our example that the end behavior asymptote is 3. Oh, this is really annoying with my camera. Rats. Rats. Is this just going to be what's going to keep happening? I really hope not. Rats. I really got to fix that. I got to fix that. Ugh, it's annoying. It's probably just a loose cable or something. All right, so that's what we got with the end behavior asymptote. Now, there's another case. Case 2, what if they're the same? If the degree of the denominator is equal to the degree of the numerator, the end behavior asymptote becomes a fraction. It becomes the leading coefficient of the numerator divided by the leading coefficient of the denominator, and then plus any vertical shift that you have. So that may seem like kind of complicated and confusing, but if you take a look, the leading coefficient of the numerator is 2. Like, see this little example over here? What if I had 2x divided by x minus 1 plus 3? Your leading coefficient of the numerator would be 2. Your leading coefficient of the denominator would be 1. So 2 divided by 1 is 2, plus 3 is 5. So don't panic and feel like that's a big complicated thing. We're just looking at the leading coefficient here divided by the leading coefficient here, and then plus whatever vertical shift there is. Okay. Last but not least, if we find that the degree of the numerator is the larger one, this was what's called a slant asymptote. We are not going to cover slant asymptotes this year in Algebra 2 CP. We normally do, but this year, because of the distance learning, we decided to omit that from our curriculum this year. It is still a pretty cool thing. If you are interested in learning about it, I'd be happy to teach you in my office hours or independently some other time, but it's not relevant for our purposes going forward as far as assessments are concerned. Okay, so what that pretty much means is your function gets slanted like this or like this instead of having that end behavior asymptote be perfectly horizontal. So it results in functions that kind of look a little tilted as opposed to these curves that look relatively straight. Once we identify our asymptotes, then I know that's a lot of information, but hopefully that's not a lot of, like, that shouldn't take a lot of time to do that. That's a big block of notes. I understand that. But when you're actually looking here, you're like, oh, degree of denominator is bigger, vertical shift is 3, so end behavior asymptote is 3. Like, that's about how long it should take. Now that you do that, you can go ahead and draw your asymptotes. You can then identify 2 points to the left and 2 points to the right of the vertical asymptote. You should go ahead and test those points to see what your function looks like, because you don't know if your function is down here or up here or over here or over here, or how close or how far it is away from those asymptotes. That's why you want to test, so you can get an accurate picture. Okay? Once you do that, you can then just go ahead and plot your points by drawing curves that approach but don't touch the asymptotes. That's why you draw those asymptotes, because they're nice like guidelines as to how to actually sketch your function. And that's pretty much it. All right. Does anybody have any questions about that? Hopefully feeling all right. One thing that we did not talk about yesterday as it relates to this is how to actually find the domain and range. I say yesterday. It was like Thursday. It was many days ago. How to actually find the domain and range of these functions. So I want to add that to these notes now. Okay. If I'm looking at the domain, Again, the domain is all the values for x where this function lives, right? Where this function resides. So how far to the left does the function go? Well, it goes forever. How far to the right does the function go? It goes forever. But it's not connected. There is a clear gap in your x values here in that the function, if you notice, goes all the way from negative infinity to 1 on the x-axis. It does not include 1, though, because that's what gave us the vertical asymptote. That's what was bad news. We can't plug in 1. However, it then picks up right after 1 and goes to infinity. Yes? So you would write your domain as negative infinity to 1. That encompasses this curve over here. And then we use this union symbol that we've talked about before, 1 to infinity. Okay? Does that make sense, hopefully? The range is kind of the same idea, where yes, it does go down to negative infinity, yes, it does go up to positive infinity, but there's this gap here, there's this break, yeah? And that break occurs at y equals 3. So your range goes from negative infinity to 3, does not include 3, but then goes everything bigger than 3. Notice that I'm using the parentheses indicating that we are not including those values. Negative infinity to 1, union 1 to infinity means it goes from everywhere less than 1 to everywhere bigger than 1, just not 1 itself. The range being negative infinity to 3, union 3 to infinity, everything less than 3, everything bigger than 3, but not 3 itself. Any question about domain and range as it relates to those things? Feeling A-okay about that. All right. Now, like I said, I want to, what do we got, about 17 minutes to go. I want to go ahead and just bang through a couple examples, right? We're just going to go ahead and grind through some examples just so you see a bunch of practice problems done for you. All right, let's check out this first one. Okay, what if I said, here's my function. I would like you to sketch a graph of 3 over x minus 4 plus 1. Okay? First step is to go ahead and identify our vertical asymptote. For this function in particular, our vertical asymptote is whatever x value would result in dividing by 0. So you should be able to see here that that would be x equals 4. Oh, the camera is giving me all issues. Oh, this is so annoying. Oh, I'm so sorry. Bam. There we go. Comes right back. I don't know why. It's really bugging me. All right, so your vertical asymptote is x equals 4 because 4 minus 4 is 0. Your end behavior asymptote, you would go ahead and compare the degree of the numerator and denominator. The degree of the numerator, if you notice, is 0 because there's no x's up there. The degree of the denominator is 1. It's x to the first. Therefore, the degree of the denominator is larger. And if the degree of the denominator is larger, like we just said over here, degree of the denominator is larger, your end behavior asymptote is 0 plus the vertical shift. So it's 0 from this piece plus the vertical shift. It's y equals 1. Okay, see how actually quick that is in practice? I know it's a big chunk of notes, but it doesn't actually take very long to do. Now I can go ahead and sketch a graph. So my vertical asymptote's at 4, so that's why I'm going to make a lot of room on this side. Okay, and our end behavior asymptote's at 1. So let's put our vertical asymptote 1, 2, 3, 4 right here. Our end behavior asymptote at 1. Right there. Now we can go ahead and test points. Since our vertical asymptote is at 4, we should test 2 points to the left and 2 points to the right just to see what it looks like. And by test, I mean create a table of values and then plug it into the function. Again, our vertical asymptote is at 4, so I'm going to elect to test 2 and 3. 4 is the vertical asymptote, and I'm going to do 5 and 6. Okay? That's just 2 to the left and 2 to the right. Just like when we were doing parabolas way back when, you may remember we found the x-coordinate of the vertex, and we were like, okay, now test 2 to the left and 2 to the right and make sure you get an accurate picture. It's the same idea. All right. So now that I know that, I can go ahead and take these values, plug them in for x, and see what I get. If I take 2 and plug it in, 2 minus 4 is negative 2. 3 divided by negative 2 is negative 1.5. Plus 1 is negative 0.5, or negative 1/2. That's just about here. Then we got 3. 3 minus 4 is negative 1. 3 divided by negative 1 is negative 3, plus 1 is negative 2. So I got another point at 3 comma negative 2. Okay, I'll hold off on sketching the curves. We can go ahead and plug in 5. 5 minus 4 is 1. 3 divided by 1 is 3, plus 1 is 4. point at 5, comma 1, 2, 3, 4. And then we'll take 6 and plug it in. 6 minus 4 is 2. 3 divided by 2 is 1.5, plus 1 is 2.5. So here's 6, comma 1, 2 and a half. Okay. Hopefully you notice how those points are symmetrical around this intersection of the asymptotes here. And now I can just go ahead and draw in curves that approach but don't touch the asymptotes. So take a look. Approach but not touch. Approach but not touch. Just like that. That's why it's handy to draw in those asymptotes, because they serve pretty much as guidelines for how you should be able to sketch your function. Okay. Any questions, comments, concerns about that? All right. Last but not least with this guy, we go ahead and find the domain and the range. You may have already made the connection in your head, and it's absolutely true that I'm already frozen again, I can tell, that the domain refers to the, it pretty much just skips over your vertical asymptote, right? Your domain is negative infinity to 4, union 4 to infinity. And the range is negative infinity to 1, union 1 to infinity. Okay? Feeling good about that, hopefully? Any questions about that as I do this quickly? Really annoying. Fantastic. Fantastic. All right, let's go into another problem. Okay. How about something like this? Again, we're just grinding out some problems. F of x is equal to, how about 2x divided by x minus 1 and then minus 4. And I asked you to go ahead and sketch a graph of that. Same deal. Identify the asymptotes, sketch them, test points, plot them. So we got our vertical asymptote. Vertical asymptote is whatever value for x results in dividing by 0. In our cases here, it's x equals 1. We then have our end behavior asymptote. Do you notice why it's x equals 1? Because 1 minus 1 would make 0. Hopefully you understand that. End behavior asymptote. I compare the degree of the top and the bottom. What's the degree of the numerator? Well, the degree of the numerator is 1 because we have x to the first power. Note that a common mistake that a lot of students make is they'll say that the degree of the numerator is 2 because there's a 2 here. No, no, no. Degree refers to the exponent. It's x to the first, so it's degree 1. Here, the degree of the denominator is also 1, so they have the same degree. Ooh, this is case 2. If they have the same degree, then your end behavior asymptote is the leading coefficient of the numerator over the leading coefficient of the denominator plus the vertical shift. So let's see what that looks like here. Leading coefficient of the numerator, 2. Leading coefficient of the denominator, 1. So 2 divided by 1 is 2. Minus 4 is negative 2. Okay. Does everybody see, hopefully, and understand, hopefully, how that was done? Again, the case 2, I know when you see it on paper, it looks scary, but it's not as scary as it looks. Now we can go ahead and sketch. So draw a graph. Nice coordinate plane here. My vertical asymptote is at 1. My end behavior asymptote is at negative 2. Right there. Another common mistake that happens a lot is students mix up their vertical asymptote and end behavior asymptote. Remember, your vertical asymptote is going up and down because that's what vertical means, and your end behavior asymptote is going left to right. Okay? Now we can go ahead and test points. Since our vertical asymptote is located at x equals 1, we're going to pick 2 points to the left and 2 points to the right. So I'm going to pick negative 1 and 0. That's 2 to the left of that x coordinate 1, right? Negative 1, 0. It's just counting. And then 2 to the right, 2 and 3. Okay, let's plug them in and see what they look like. Negative 1 goes in. Keep in mind you're plugging in both to the top and the bottom. Sometimes when you have this case 2, it's a little easier to write it out. I know when there's only one plug-in, it's easier to do it in your head. Sometimes with 2 plug-ins, it's easier to do it if you write it. So on the top, I'm going to get negative 2 over. Negative 1 minus 1 is negative 2, and then minus 4. Negative 2 divided by negative 2 is 1. Minus 4 is negative 3. So I got negative 1 comma negative 1, 2, 3 right there. Okay. We can go ahead and take 0 and plug that in. On the top, you get 2 times 0 is 0. On the bottom, you get 0 minus 1 is negative 1, and then minus 4. 0 divided by negative 1 is 0. Minus 4 is negative 4. See another point right there. Okay, let's go ahead and plug in 2. 2 goes in. On the top, you get 2 times 2 is 4. On the bottom, 2 minus 1 is 1. Minus 4. Here you just get 4 minus 4, which is 0. Nice and simple. 2 comma 0. And last but most certainly not least, we plug in 3. On the top, you get 2 times 3 is 6. On the bottom, you get 3 minus 1 is 2. Minus 4. 6 divided by 2 is 3. 3 minus 4 is negative 1. Okay. Does everybody see how that was done, hopefully? Now we can go ahead and just sketch our curves. Again, approaching but not touching the asymptotes. Notice how they're smooth curves that approach. They're not hard right angles, but do not touch the asymptotes. Okay? Last step, just domain and range. Our domain, again, left to right. It goes left forever, it goes right forever, but skips over this value of 1. So our domain is negative infinity to 1 union 1 to infinity. It's literally everything except 1. It just skips 1. And then our range, negative infinity to negative 2 union negative 2 to infinity. Okay, everything less than negative 2, everything bigger than negative 2. Okay. Questions about that? I have to do this like 5 times. Feeling good. Feeling happy. Everybody's A-okay. Alrighty. Okay, let's do another one. What do we got? 7 minutes? Probably definitely do at least one more. Okay? At least one more. How about something like this? We got x minus 4 over x minus 3. Okay? And then plus 5. That's a good as problem as any, right? We can go ahead and tackle that. First of all, our vertical asymptote. We're looking at the denominator. What value for x in the denominator makes that equal to 0? It's 3, because 3 minus 3 would be 0, right? That's the bad news. That's what we could not plug in, right? In the numerator, in behavior asymptote, I'm going to look at the, I got ahead of myself there. I'm going to look at the degrees of the numerator and denominator. In the numerator, degree is 1. In the denominator, degree is 1. I have 1 divided by 1, which is 1. And then plus 5. By the way, I just want to be very clear. I realized I was saying that. That may have been confusing. Degree 1, degree 1. So we look at the leading coefficients. We don't divide the degrees by each other. That's another common mistake a lot of students make. We divide the leading coefficient of 1 here, divided by the leading coefficient of 1. 1 divided by 1 is 1, plus 5 is 6. Okay? That made sense, I hope, right? I hope I didn't lose anybody there. When we compare the degree, they have the same degree. So I'm going to divide the leading coefficient at the top by the leading coefficient at the bottom. 1 divided by 1 is 1, plus our vertical shift of 5. Now I can go ahead and sketch a graph. Notice since our vertical asymptote and behavior asymptote are kind of like far into the first quadrant, I'm going to go ahead and leave a lot of space up there so I don't waste a lot of space on my paper. Right? My vertical asymptote is at 3, right about there. My behavior asymptote is 6. 1, 2, 3, 4, 5, 6. And now let's go ahead and test some points. Again, 2 to the left, 2 to the right. So let's go ahead and plug in 2 to the left of the vertical asymptote, 1 and 2. 2 to the right of the vertical asymptote, 4 and 5. Okay? So if I take 1 and plug it in the top, notice I'm going to get 1 minus 4 is negative 3. On the bottom, 1 minus 3 is negative 2, and then plus 5. Negative 3 divided by negative 2 is positive 1.5, plus 5 is positive 6.5. Okay, meaning that we got a point at 1, comma 6.5. Here's 6.5. Okay. 2 goes in. On the top, 2 minus 4 is negative 2. On the bottom, 2 minus 3 is negative 1, plus 5. Negative 2 divided by negative 1 is positive 2, plus 5 is 7. So another point right there. Very good. 4 goes in. In the numerator, I get 0. That's 4 minus 4. On the denominator, I get, it really doesn't matter, but I get 1. And then plus 5. 0 plus 5 is, of course, 5. 4, comma 5. And last but not least, 5 goes in the numerator. 5 minus 4 is 1. In the denominator, 5 minus 3 is 2, plus 5. 1/2 plus 5 is 5.5. Right there. Bam, look at that. Hopefully, even before we even sketch those curves on the graph, you should be able to get a mental image of what that's going to look like, right? A curve that approaches but doesn't touch the asymptotes here, and a curve that approaches but doesn't touch the asymptotes here. And again, domain and range before we wrap things up. Our domain are all the x coordinates. We're looking left to right. How far to the left does the graph go forever? How far does it go to the right forever? But it skips over 3 because that's our vertical asymptote. So it's negative infinity to 3, union 3 to infinity. And our range, same deal. It goes forever down, forever up, but it skips over this value of 6, negative infinity to 6, union 6 to infinity. Okay? And that's that. That is a complete graph of that. Okay? Does anybody have a question, comment, or concern about how that was done, even in the slightest? No questions, no comments, no concerns, even in the slightest. All right, that should have been a nice array of examples for you, a nice collection of examples for you to go ahead and get started on that practice work. The practice work that I gave you that I expect is done by Thursday is 6 problems, or actually it's not posted yet. I will post it at the end of the day today. It's 6 problems. The answers will be provided. That's why I still have to work on the answer key. The answer key will be provided for you, so you can go ahead and check your work. Again, it's not graded, but it is just extra practice for you to get a good understanding of what's going on. All right, it's only to your benefit to make sure that you do it. All right, if you don't have any other questions or concerns, that's all I have for today. Just made sure I went through a couple examples for you. I do hope you have a fantastic rest of your day. Your grades are posted. Good job on the summatives, by the way. They went overall very, very well. And I hope you have a great rest of your day. All right, ending a couple minutes early today makes up for last time when I kept you a couple minutes later. All right, see you guys. Enjoy the rest of your Tuesday. Again, make sure you sign in for attendance if you haven't done so already. And I am going to try, before my A2 class starts, to fix my camera and make sure it doesn't do that. It's probably just a loose connection. Let's make sure. Kaden, have a great day. Have a great day, everybody. See ya. Bye, Ryan. See ya.